All right. Hello, ladies and gentlemen. Today I'm taking a look at the force of gravity questions that I handed out yesterday, and we're going to go through those. And if you have some, hopefully that will answer some of the questions you might have. And if you have further questions, please do not hesitate to ask. That's what you're supposed to do. Okay, just trying to get things set up here. There we go. All right. So, Science 10 of force of gravity questions. So, here we have what is the force of gravity in newtons of a 32 kilogram rock? Right. Again, the process that I want you to go through is to go through, make sure you read the question, and pull out the information that's important. So, here we have a 32.5 kilogram rock. Well, anything that's measured in kilograms, and this is where the units are important, anything measured in kilograms is going to be a mass. There are no other numbers in here, but there is the question, what is the force of gravity? So our force of gravity is what we're going to be looking for. That's the question. Well, what formula do we have? The only formula we actually have at this point is Fg is equal to mg. And we'll sometimes put this is a crutch. This is something that helps you get through without having to know the how to do the algebra, but it's just this relationship here. And we can cover up parts of this, cover up the m. If you want to find the mass, you take the force of gravity divided by g. Well, what's g? G is, anyone remember? The gravitational field strength. Don't say it's gravity. It's not gravity. That's a value of 9.8 newtons per kilogram here on the Earth. Go to a different planet, it's going to have a different value. All right. So this is all the information that we need. Part of this we have to know. That can be on your cheat sheet and so on. We're going to be working from here. So our force of gravity, we substitute in our values. Force of gravity is our mass. Our mass is 32.5 kilograms. And then we're multiplying it by g, and g is equal to 9.8 newtons per kilogram. Kilograms cancel out with kilograms, we're going to be left just with newtons. 32.5 times 9.8 on my Casio FX260 Solar gives me a negative number. I did something wrong. 32.5 times 9.8 equals, there we go. So the force of gravity is equal to 319 newtons. There you go. Now, you might have said 318. I've got 319, maybe even 320. The point here is when it comes to marking a test where I'm always expecting there will be some variation in the calculations because there's certain assumptions that are made as we go along. All right, here we have the next question. What is the force of gravity on a box that has a mass of 7.8 kilograms? So here's our tabletop. Here's our box. Let's put some humor into this. And it's upside down. All right. So here's our number, 7.8 kilograms. What is that? Well, that's a mass. So we write that information down. We're summarizing the information. No other numbers in here. What is the question? What is the force of gravity? So force of gravity is what we are looking for. Well, the formula we're going to use, Fg is equal to mg. So we need to know what g is, 9.8 newtons per kilogram. Now, you notice that I'm putting this in, summarizing this over on the left-hand side. I'm doing that right now just to emphasize the point that we're talking about this gravitational field strength and that you need to be including it and it's part of the information. If you just included it, substituted in here in the next step, that would be fine. But really, I'm expecting to see some summarization. I'm expecting to see the formula. I'm expecting to see numbers substituted in. So 7.8, even if you don't include the units here, 9.8, 7.8 times 9.8, 76. newtons. Now, I am expecting to see the unit. Just saying 76 would not make me look favorably at you. A question like this is generally going to be worth like 3 marks. Now, over here, I'm going to generally give you 0 marks for this, but this is just a good habit to get into. 1 mark for showing me the formula, 1 mark for showing me the substitution, and 1 mark for the answer with the proper units. That's generally how I would mark a question like this, and this is what I'm wanting to see. If you went through and just said, hey, force of gravity is equal to 76 newtons, and then, for question number 2 type of idea. Well, depending on how I feel, depending on whether I like you or not, I might give you 3 marks, I might give you 1 mark. Depending. Have you shown me stuff worth 3 marks? No. Have you gotten the correct answer? Yes. But maybe you got the correct answer by looking at your friend's paper. No, you would never do that. But this is the point. When I see this, I just don't know. But let's say you did the force of gravity is equal to 27 newtons for this. Well, I can tell you right now, this is worth 0. It's wrong. Here you had the correct value, so I might give you the full marks for this, saying I'm assuming that because you have the right value, that you did the steps correctly for coming up with this value. Here, you don't have the correct value, and there is no work for me to give you partial marks, so you're going to get 0. Like back over here, let's say you got 27 newtons for the answer here, not the 76. Well, I'm going to say, all right, you showed me the correct formula, you substituted in the values correctly with the correct quantities. I'm going to give you 2 out of 3 on that. That's how I'm going to mark this. This part's wrong. Your calculator hiccuped. You weren't using a Casio FX260 Solar. Something happened. But here you're showing me that you understand how to do the question. And this really brings up a point, and I say this to classes at different times. When you're doing a test, when you're doing questions like this, you're not telling me the answer. The answer is important, but you're telling me how to get the answer. And so you need to be taking me, so not and just the answer, but how to get the answer. This is the key part. This is the important part. So I want you to go through and show me all these steps. Now you might say, well, do I have to do that on my homework? You're not even taking it in. Well, the answer is you can choose not to, because you're right. I'm not taking it in. However, if you're not in the habit of doing things this way, when it comes to a test or a quiz, there's a good chance you're not going to do it this way, and you might just hurt yourself. All right, next question. Ignore these numbers here. They're meaningless. What is the weight and force of gravity of a 3.3 kilogram chicken? I'm sorry, but this requires a chicken. And let's give it an egg. There we go. All right. So this is a 3.3 kilogram chicken. Go through the question. What information do we know? 3.3 kilograms. 3.3 kilograms. What is that? Well, that is a mass. What is the weight, the force of gravity? This is the key point. Now, we use weight and mass as if they're the same thing. They're not. When we talk about the weight, we're talking about the force of gravity that an object has. When we're talking about mass, we're talking about the quantity of matter that we've got. This does not vary anywhere in the universe. The weight varies depending on where you are in the universe. So things weigh less on the moon than they do on Earth, but they all have the same mass on the Earth and on the moon. Subtle, I know. Force of gravity is what we're looking for. We need to know 9.8 newtons per kilogram. All right, Fg is equal to mg. Okay, this is from Physics 11 and 12. I just put these arrows in up here that tells me this is a vector, and that's why it happens. Okay, sorry. 3.3 kilograms. We put in our values, 9.8 newtons per kilogram. 3.3 times 9.8 equals 32 newtons. There is our force of gravity. There is our weight of our chicken. All right. What is the mass of a 43.1 Newton rock? Let's go through 43.1 newtons. So that's our mass, right? No, that's our force of gravity because it's measured in newtons. The units help to tell us what quantities that we're looking for. What is the mass? M. That is what we're trying to find. So we're still needing a G of 9.8 newtons per kilogram. All right. Different ways of looking at this. We can go Fg is equal to mg. We need to know what m is. So we're going to divide both sides by g, g divided by g, 16 divided by 16, 12 divided by 12, x divided by x is equal to 1. That drops out. And so our mass is equal to our force of gravity divided by gravitational field strength. Or we can remember that we have F, G, M, and G, and we're looking for the mass. So we cover up this, and we can see we're going to take the force of gravity and divide it by the gravitational field strength. That's how we're going to find out. So if we cross this out, that's how we're going to find out the value. All right, our force of gravity, well, that's 43.1 newtons. And our gravitational field strength, 9.8 newtons per kilogram. So we go 43.1 divided by 9.8, and that's equal to 4.4 kilograms. That is what the mass is. Big rock. All right, what is the mass of a 58.7 Newton fish? Well, I think this requires a picture as well. Is this an anglerfish? There you go. And then I guess we need big teeth. There you go. Anglerfish are ugly. Anyways, we have this 58.7. What's the unit? Newtons. Oh, that's our force of gravity. What is the mass? Mass is what we're looking for. So we need to know G, which is equal to 9.8 newtons per kilogram. All right. So our mass is equal to our force of gravity over G. How did we get that? M, G, F of G. There we go. So our mass is equal to 58.7 newtons divided by 9.8 newtons per kilogram. Using my Casio FX260 Solar, we get M is equal to 6.0 kilograms. There we go. Easy peasy. What is the force of gravity on a 325-gram book? All right, only number we have in there is 325 grams. So what we have here is a table, and we've got a book, and it's lying there. And we've got the force of gravity pulling it down. We want to know what that force of gravity is. So this is its mass. Force of gravity, that's what we're looking for. We need G, which is equal to 9.8 newtons per kilogram. And this is where we run into the problem. That's the trickiness. Here, the units are grams. Down here, the units are kilograms. Units have to match. So we have to have our mass in kilograms. How many grams in a kilogram? There's 1,000 grams in 1 kilogram. That's 3 zeros. So we're going to be moving the decimal place over 3 places. 1, 2, 3. 0.325 kilograms. Kilogram is larger than a gram, so it's going to be a fraction of a gram if we just got a fraction of a kilogram. All right, so Fg is equal to mg. So now we can take our 0.325 kilograms, multiply that by our 9.8 newtons per kilogram. Here we go, 0.325 times 9.8 is equal to 3.2 newtons. There's our force of gravity. Coolness. All right, last one. If a 17 kilogram dog has a weight of 28 newtons on the moon, what is the gravitational field strength there? Ooh, this is a different question. Well, we got 17 kilograms. 17 kilograms. Well, what do we measure in kilograms? Mass. Okay, that's our mass. Here we have 28 newtons. 28 newtons. Well, what is that? Well, here we talk about a weight on the moon, 28 newtons. That's our force of gravity that's happening on the moon. And so then the question is, what are gravitational field strength? Well, what symbol is our gravitational field strength? G. Well, isn't that equal to 9.8 newtons per kilogram? That's on the Earth. And are we on the Earth anymore? No, we are on the moon. Okay, so here's our moon. Here's our craters. And this is how we know we're on the moon. Here's a footprint. Here's another footprint. Here's our boot. Here's our other boot. Little bar going across. And this is our there's our spaceman on the moon. Anyways, but it's a dog. Oh, we do a spaceman. All right. So we're looking for G. All right. So if we come back to this, we have Fg is equal to m times G. So now we're looking for G. So if we cover up G, we can see that G is equal to our force of gravity divided by our mass. Force of gravity on top divided by our mass on the bottom. Our force of gravity then is equal to 28 newtons. And our mass, which is in our kilograms, is equal to 17 kilograms. So if we go 28 divided by 17 equals, this is G on the moon, and that's equal to 1.6 newtons per kilogram. So the questions we've been doing so far have been asking for the force of gravity given a certain mass, or a mass given a certain force of gravity. This last question is asking for the gravitational field strength given a mass and a weight or a force of gravity. We have an equation that has three variables, three things to it, or two variables and one constant. But that constant changes depending on where you are in the universe. And so we can ask questions about all three. And that's where the triangle like this can be helpful, just, if you're having difficulties um, with knowing how to do the algebra. We draw a triangle, we draw it like this. And so the formula is Fg is equal to mg. This is m times g, so we have m times g. This is Fg, so that's on the top. And whatever we are looking to find, we cover up. So we cover up the m, so that tells us m is equal to force of gravity over g. If we're looking for a little g, that's going to be force of gravity over m. So g is equal to force of gravity over m. And if we're looking for the force of gravity, well, that's what we figured out is m times our g. These are the three forms of the equation. So you can always make sure you have that on your cheat sheet, and you'll be good. All right, that's it for today. Uh, Maybe we should have a little quiz tomorrow. And if we have a little quizzes, then we don't have to have a big test. That sounds better. So, anyways, talk to you tomorrow. Take care.